Welcome to 10C, which is describing restricted and discontinuous domains and ranges. So quick definitions of domain again is describing all of the, so we're representing all of the x values of your graph of the function. And range is the same as the domain, except it's all the y values. So we're describing all of the y values of the function. And how I explain it a lot of times, domain, we do that left to right, so explain all the different parts of the graph left to right. And range, we explain that with going, start at the bottom of the graph to the top of the graph. It's from the negatives to the positives. So let's jump into this. So now we're dealing with asymptotes. We've talked about asymptotes in previous learning targets. So with the domain here, there are three different parts to this graph. So there's going to be three different parts to our domain. From left to right, there's three different parts. So we first still look off to the left, and we still see there's an arrow here that's coming from negative infinity. So our domain is going to start with negative infinity. And then where is that part of the graph? Where is it discontinuous? And that looks like there's an asymptote right at -1. So that's going to be my first part, the domain. Now the domain is also going to continue between -1 and 2. So we have to join that. So you're joining it with union -1 to 2. We do not put brackets around these because -1 and 2 are asymptotes. Your graph does not have a coordinate, a point on those asymptotes. So that's why they're not included. And we're going to have one more part to this graph, and that's describing from this asymptote of 2 to, and it goes to the right forever and ever and ever to infinity. So 2 to infinity. If you don't like writing them like this, there's a different way you can write this. I don't mind if you do this, and a lot of teachers don't mind if you do it. You could write this domain as x is all real numbers, so it's a little symbol, it's like an E, and then an R with a double backbone. So that's x is all real numbers such as x cannot equal, and you just write down the asymptotes, -1 and 2. So you could write it that way too. Either way, the domain is fine. There's actually one other way I can show that in class. Range-wise, so the lowest part of the graph to the highest part of the graph. So the lowest part of the graph is down here. The lowest, both these arrows are going to go down, so that's negative infinity on the y values. So negative infinity to, and look for an asymptote. There's an asymptote right here at 0, you can see. So it's going to go to 0. And I know there's three parts to the graph, but range-wise, there's multiple parts that are, like if I stopped here at 2, there's the y value, there's 2 parts to the graph that's at 2. I just want to name all the y values that have the graph is at. So all I'm looking at from there's one asymptote. Both these graphs go up and up and up forever and ever along the asymptote. So they're going to go from 0 then to infinity. So left to right, there are 3 different parts that, because we had 2 different asymptotes, but up and down there's only one asymptote, so there's only 2 different parts to that graph that we have to explain. Example 2. Let's look at this on the calculator. So I put that in the calculator, the function, graph it. You can see that there's an asymptote here. We're going to go, you want the discontinuities. So look for all your discontinuities. And it looks like, just to cut down on time, looks like they're only at 1 and 2. Are the only discontinuities. Those are the errors. So at 1 and 2, those are your discontinuities. That's where your graph is discontinued at x equals 1 and 2. So on the domain, that's where x is discontinued. So the domain is going to go from negative infinity to 1, union 1 to 2, union 2 to infinity. Now you can look at the graph, and you can see that there's a vertical asymptote at, looks like 1, and there must be a hole at 2, since there's no vertical asymptote there. So you can write it this way, just like up top. You could also write, and this might be easier, x is all real numbers, but x cannot equal 1 and 2. You could write it that way too. I just like to stay keep with one thing and just keep doing that. Range. The range is all y values except for, looks like there's a horizontal asymptote, and you always find the horizontal asymptotes from the beginning here. The exponents, so they both are square, both squared exponents, so therefore it's y equals 3 over 1 is the horizontal asymptote. Y equals 3 over 1, which is 3. So the range is going to go from negative infinity to 3 and 3 to infinity. We can look back at the graph again to just make sure that's right. So coming from negative infinity up to 3 is the asymptote, and then just on the other side of 3 up to infinity. So there we go. You could also write this, y is all real numbers, and you could say y does not equal 3. So you could write it that way. Let's quickly do log. So put it in the graph, log. The log button is right next to the 7, so you might need that at some point. Hit the log, go to graph it. Anything you're going to need to know about log, you're going to have to remember that log has a tail that comes down. And there's an asymptote that runs right along. And that's the first time you heard about an asymptote this year, is the asymptote runs right along the tail. So in this case, the asymptote's at 1. You could look at the table, and you're like, wow, there's a lot of errors. Well, it's the last error in this case. When there's a lot of errors like that, the last one is the actual asymptote. So at 1, there's an asymptote there. So we would say domain-wise that it's going to go from 1 to infinity. And that's it. There's only one part to the graph. It starts at 1 and it goes to the right forever. So the farthest left point is 1. Range-wise, it looks like it starts here at negative 1, but it actually doesn't. There's a tail that runs down here. Log functions are continuous with, it doesn't have a starting point. So the range goes from, in this case, and it's very deceiving, it goes from negative infinity to infinity. You might have to look back at your notes from first unit of the year to gather that. That's the end of the notes for this class. For next class, and if you want to try one, here's one problem to try with domain and range. This is actually from last class. So if you'd like to try this to make sure you understand from last class, I'll give you a couple seconds, and then I'll put up the answers. You can pause it right now, and then I'll put up the answers. And here are the answers. Don't forget that 0 here has to have a bracket on it because there's an actual coordinate at negative 2, 0, and the range is the y value, so it's 0. Again, this was actually 10b that you tried here. We're going to try out 10c in class. So hopefully you understand. If not, come to class, ask me a lot of questions. Thank you.